Okay, numerical solution of equations. Now, you people know how to solve an equation like if there is something x squared minus 4x plus 3 equal to 0. You know how to solve it. You know how to solve sine square x minus 5 cos x that is equal to 0. You know how to solve this trigonometric equation. We even know how to solve an equation if it is e raised to power x that is equal to 2. Okay? You people know how to solve this equation. So, you have studied all about these quadratic, cubic, trigonometric, logarithmic, exponential functions, how to solve these equations. But the problem comes when you have to solve an equation like this. For example, you have an equation e raised to power x and plus x that is equal to, let's say, 5. Okay? Can anyone tell me how to solve this equation, e raised to power x plus x that is equal to 5? Clearly, we do not know how to solve this equation. Okay, so this topic, numerical solution of equations, will help us to be able to solve such equations which have more than one functions within one equation. Okay? Now, there are basically, this method consists of 3 different ways to get to the solution of this equation. Now, first of all, if I write this equation as e raised to power x that is equal to 5 minus x, okay, and then I write that equal to y. Now I have 2 equations out of this one equation. One is y is equal to e raised to power x. The other is y is equal to 5 minus x. If I draw there, like, sketches of the graphs in one diagram here, you see that this is something like e raised to power x. And here's the line y equal to, like, something like this, y equal to 5 minus x. Okay? So the point where these 2 graphs, they're intersecting, that is going to give us the solution to this equation e raised to power x plus x that is equal to 5. So first of all, we have an idea of their solution through the graphical method. Okay? We divide our equation into 2 equations and we plot them on the same graph, and then we got, now this is not going to give you an exact value. There's just an idea that this is going to be, if you have a scale over here, like you have a 5 over here, there is 0. So maybe you can have an idea that the root is between 0 and 5 over here. Okay? The solution is between 0 and 5. So that is the first way of reaching the solution of an equation, which is not directly in terms of one function. Do you have any questions so far?
No, sir.
Okay.
No, sir.
Okay, now the next method is, the second part is the hit and trial method. Now, this hit and trial method is very much relevant to the factor theorem. If you people remember that when you had f of x equal to blah, 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 and if your f of 1 was equal to 0, so then this would mean, okay, yes, x equal to 1 is a root of this, whatever the polynomial we have over here. Okay? But in this case, this is going to be a very, very complicated equation over here, e raised to x plus x that is equal to 5. So how to use that hit and trial method over here, okay? So let me tell you. Now this is e raised to power x plus x that is equal to 5. You will first of all write it as e raised to power x plus x. We'll bring all the terms to one side. and then you can name it as your f of x or whatever. Okay? Now, instead of looking for that root, that will be uh, very impossible here to find that, I mean, that integer root over here, because you see these are all irrational things here. E is an irrational number. So this is rarely going to be a situation when you get an integer value. So we're not going to look for a value where your f of a is going to be 0. Instead of that, we will be looking for two consecutive values. Like, for example, if you find, let's say you find f of, let's say 2.5, and then you find f of 3.1. So you will see that if you see that there is a change of the sign, for example, this is a positive value and this is a negative value. So this would suggest you that the root is going to be somewhere between this 2.5 and 3.1. Now suppose the curve is going to be like this. Now here it is your 2.5 and here it is your 3.6. Now at 2.5 you have a positive value and at 3.6 you have a negative value over here. So this means that the graph should have passed between through this x-axis between 2.5 and 3.6. Now, luckily, you don't have to go for all these trials in your syllabus. You only have to test. For example, if you people, let me just pause this. So now, in this question, we have one of the equations y is equal to 6 over x squared. The other equation is y equal to x plus 1. And there should be a question here that show through a sketch of the graphs on the same diagram that there is a solution to these two equations. But this is not the question here. If you look at the first part, it says verify by calculation that x coordinate of p lies between 1.4 and 1.6. It says the root, for example, if that root is that lies between 1.4 and 1.6. Now, these are two graphs, they are intersecting at a point P, and that point P's x coordinate lies between this and this. So basically you have to combine these two equations first of all. So 6 over x squared, that is x plus 1, and you will bring all the terms to one side. This will become 6 over x squared minus x minus 1, that is equal to 0, and you name this as f of x. Okay, now you have the calculators with you. Please find what is f of 1.4 and tell me what is f of 1.6. Now, this is f of 1.4, which is 0.166. And now you see that we have to show that, yes, if this one is going to be positive, then this one is going to be negative. So you will write here in the answer that the change of the signs suggests that there is a root between 1.4 and 1.6. So you must be clear about this, how this is happening, that when you find f of 1.4, so it is positive. So that means if there was a curve over here, let's say if it was the curve like this, then this is going to be 1.4 over here, and this is going to be 1.6 over here. And the curve has passed through the x-axis between these two values of x. So this is verified through the calculation. This is shown through the calculation. Yet yes, the root is between 1.4 and 1.6. Okay, let me give you one more example. So we have the equation here, e raised per 2x, that is equal to 14 minus x squared. For the first part, it says, this is a question from June 11. Okay, this is a past year question from June 11. It says, show that this equation has exactly two real roots. Exactly two real roots. Now, you must be very good at the sketches. I'm going to draw them roughly here. So this is your e raised to power 2x. It's going to be 1 here. This is e raised to power 2x, okay? And then for the 14 minus x squared, if I have 14 somewhere here, this is not according to the scale. This is going to be a sad face like this, a downward curve like, oh sorry, like this, okay? So you see that this is intersecting, they are intersecting at, they're intersecting twice, okay? So you have 14 over here. So that is the first part. It says show through the sketches on the same diagram that there are exactly two roots for this equation. I have done that, okay? And then the second part, it says show that this root also, sorry, the second root says show by calculation that the positive root lies between 1.2 and 1.3. Now, why does it say positive root? Because there are going to be two roots. This area is going to give you the positive value here, and this is going to give you a negative. So it says the positive root lies between 1.2 and 1.3. So what will you have to do for that? You will bring all the terms to one side. This is e raised to power 2x plus x squared minus 14, that is equal to 0. And you will name it as f of x or g of x or h of x. Now you must have the calculators. Tell me quickly what is f of 1.2, and then tell me what is f of 1.3. Yes, quickly. So we have got these two values, f of 1.2 is this and f of 1.3 is this. So you see that there is clearly a difference of signs. This one is negative. You have to show that one of these two values is negative and the other is positive. So this means the change of the sign shows that there is a root between 1.2 and 1.3. Now in the next video, I'll be taking you to the third level of this, third part of this method, which is known as the numerical solution of equations.